Hi, everybody. I'm Mr. Hayes. This is Mr. Hayes' World of Math. Welcome back. We are doing AP exam review for AP Stats. We're talking about sampling distributions, and we're going to look at free response questions from that. Now, all of this can be found down below. There's a link I just read. All right. So, with that being said, we're going to jump right in. Oh, and by the way, while you're down there looking at the amazement of what this is, he said sarcastically, throw a like, subscribe, comment, any of that type of stuff. And hopefully, if you're finding it works, that's great. If there's something else that would be helpful, let me know that too. So, as I said, we're going to be doing sampling distributions. A lot of this has been kind of roped into some of the other questions, more about confidence intervals and testing. Prior to potentially last year, the questions came from like 2014 and 2010. So it's not a super common type of thing. But again, all the concepts are going to be stuff that you're going to use. So in this case here, schools in a certain state receive funding based upon the number of students who attend school. So to determine the number of students who attend school, one day is selected at random and the number of absences counted, or the student attendance is counted, and the daily number of absences at high school A is approximately normally distributed with 120 students absent and a standard deviation of 10.5. Now in the back of your head, you should be thinking standard deviation, mean, okay, probably going to do something with z-scores here. So let's see what question A brings us. If more than 140 students are absent on a day that the attendance is counted for funding purposes, the high school will lose some of its state funding for the subsequent year. Approximately, what's the probability high school A will lose some of its state funding? So notice here, I've got the normal curve because they said it is approximately normally distributed. That is important. Let me get out my highlighter, which is even more important. Now, again, you can't use highlighters on the test. However, you can use blue and black pens. So I give my students blue pens so that they're writing in pencil and they're highlighting information in pen. So mean of 120 and standard deviation of 10.5 students. So when you go through and do that, we want higher than 140. So my z-score is going to be x minus x bar over standard error, standard deviation, 140 minus 120, that looks like a plus, I'm sorry, over 110, and you get a z-score of 1.905. Now, when you type that in, you can either use table A, and if you do that, indicate it up there in your Word. And then the second thing, too, is, just realized I couldn't see my preview. Then make sure if you're going to end up using your computer or your calculator for it, normal CDF, and then write out what you're using. So lower value, upper value, mean, and standard deviation. So I've got 1.905, 10 to the 99th, 0, 1, and I get a probability of 0.0287. Now the important thing here is that you always, and if you have been watching this now, watching any of the previous 6 videos, I'm very big on saying answer the question that's being asked. So here is what's the probability high school A will lose some of its funding, okay? So you need to at least tie it into this. You can't just leave it as 0.0287, okay? Some sort of summary statement, the probability that X, which is the number of school days, is bigger than or equal to 140 is going to be 0.0287. You could also write it out in a sentence if you wanted to. That would be fine. But that would be adequate for what you have, okay? So now for question part B down here, the Principals Association in the state suggests that instead of choosing just one day, what happens if we choose 3 days and take an average? Great. So with the suggested plan, high school A would lose some of its state funding in the subsequent year if the mean of the number of high school students for 3 days is greater than 140. So again, things you should be thinking about: normal distribution. What happens with distributions when sample size gets larger? It starts to get, it starts to tighten up, right? Why? Because your standard deviation is getting smaller. So again, things that hopefully you're going through your head as you're reading problems, even before you see what the question's supposed to be asking. So would the high school A be more likely, less likely, or equally likely to lose funding using the suggested plan compared to what we did back up in part A? So again, ask yourself this: what's going to change if we do a 3-day average? Is my 140 going to change? No. Is my 120 going to change? No. So what else is left? Is the standard deviation going to change? There you go. Because remember what ends up happening, and I think I have it written down here. Your standard deviation is going to go from 10.5 to 10.5 divided by the square root of 3. And so that's going to tighten up that curve. Because remember, the larger the sample size, I'm doing this a lot. The normal curve gets tighter, so the standard deviation goes down. So because of that, and could you calculate it out? Probably. Do you need to? No. What you have to say is that high school A would be less likely to lose funding. Why? Because the increase in sample size would reduce the standard deviation, and it would also then, and therefore, increase the z-score. Okay, and because of that, then the probability will go down. All right. So again, depending upon how you want to play it, if you calculate it out, if I remember the rubric correctly, they do give you credit for that. You're saying, well, I calculated it out and go from there. The key here is this step right there. Okay. Don't forget about it. And again, and part of it is that we've been doing z-scores so long. This was when we kind of really introduced playing with z-scores and what would work. This is the part that if you're going to forget about it, it's going to be that. Okay, so just don't get too excited. Or at the very least, when you do stuff like this, look through your formula sheet on the AP exam and say, oh yeah, what's that one with the square root of n? Maybe I should use that. So down here, typical high school week consists of Monday, Tuesday, Wednesday, Thursday, Friday. The principal at high school A believes the number of student absences tend to be greater on Mondays and Fridays. And so they are concerned that if one school day is random from the typical three typical school weeks, what's the probability that all those days are going to be chosen are going to be Monday and Friday? Oh, actually, I did that. What's the probability that none of those days are going to be Tuesday, Wednesday, Thursday? In other words, what's the probability that they're going to be Monday or Friday? So what's the probability? And you can play this a couple different ways. What's the probability that you're going to pick a Tuesday, Wednesday, Thursday? Oh, 3 out of 5. What's the probability of picking a Monday or Tuesday or Monday or Friday? 2 out of 5. So however you want to do it, you can do it. So we want to have what's the probability that you only get Mondays and Fridays. And that's the way I'm going to play it, because otherwise it's just, I don't know, it's just the way that I think. So what I'm going to do down here is the probability of a Monday or a Friday is 2 out of 5. You could write this as 2 out of 5 to the third power. I'm writing it out like this just to make sure that if you get stuck, you can kind of reason your way out of it. The first week, I would have a 2 out of 5 chance of getting it there. And they're independent because obviously what day they pick is not going to choose. We're assuming it's independent because they aren't saying that they're going to pick 3 different days. So 2 out of 5, week number 2, 2 out of 5, week number 3, 2 out of 5. So you're going to multiply all that out. You get 8 out of 125. So you get about 6.4%. Again, go back to saying what's the problem. So what are we asking? You can't just leave it as 0.064. This work over here, stats teachers would know what it is, but it's not adequate to answer the question. So please make sure that you go through, sorry, just checking time, and say something like the probability that there's no Tuesdays, Wednesdays, or Thursdays chosen is 0.064. Okay. Let's jump to the next one. The next one